Hello class, how are you doing? Today we're going to graph some polar functions, and I'm going to start with a vertical line, x equal to a. If a is positive, your vertical line is to the right of y-axis, and if x is negative, your vertical line is to the left. In polar, x is represented by r cosine theta, and r is a distance from a pole, and the theta is an angle from the polar axis to the terminal side. Therefore, in polar function, r is your independent variable, sometimes we call it f of t, and this one is nothing except a equal to cosine of theta. But here my domain said your theta cannot be odd multiples of pi over 2. Odd multiples means 2n plus 1 if n become an integer number times pi over 2. But I'm talking in this one, I want to know where my vertical line go from a negative infinity to positive infinity. If a become 5, therefore your vertical line become 5 over cosine theta, and this is a pole. If this becomes 0, theta becomes 0, cosine of 0 is 1, and your r is 5. But if this become pi over 6, because the cosine is always between less than or greater than equal 1, this is always a proper fraction. And any number divided by a proper fraction is going to become, value is going to be greater than that. Therefore, for any other angle, the r get bigger and bigger and bigger. What happens if this become pi over 2? Cosine of pi over 2 becomes 0, and it goes all the way to infinity. Therefore, if 5 is in cosine of 89.999999, that's going to be a huge number, a very small number, and that going to approaches to plus infinity. But if I go to the other side of a 90 degree and say cosine of 90.0000001, in a second quadrant cosine is negative, that's a very small number, and that go to negative infinity. Therefore, from approaches 90 degree from the right, it goes to infinity, and approaches 90 from the left, it's going to start from negative infinity, and it's going to come back up. And when that theta become pi, cosine of pi is negative 1, 5 over negative 1 is, that's your pi, 180 degree, 5 over negative 1 is a negative 5, and it come back right here. Therefore, the trace you go to plus infinity, then it start from negative infinity, and it come back up to plus infinity. That's the graph of a vertical line, and it only requires 180 degree for the full graph. I can say same thing about the horizontal line, which is y equal to b, and since y is r sine theta equal to a b, and r is equal to b over sine theta, if this is a pole, if this becomes 0 degree, that's the polar axis, it becomes 0. Sine of 0 is 0. Any number over 0, boom, infinity. Then the r is go to infinity as this angle, assuming if b is 3. If this become theta become pi over 6, sine of pi over 6 is 1/2, and that number becomes 6. Therefore, the r is going to decrease till you get to 90 degree. Sine of 90 degrees is 1, and you get the r is the smallest value, and you get to 3. Therefore, it's a start from plus infinity, came to 3, but after that, in a second quadrant, the sign is positive, and the r is start getting larger and larger. The minute you get to 180 degree, sine of 180 degrees is 0, 3 over 0, it go to infinity. Therefore, that graph is going to become exactly y equal to 3. That's the horizontal line and needed only 180 degrees. Next one we're going to talk about graph of circles. R equal to cosine theta. I hope you know it is very difficult to change this one to a Cartesian because Cartesian require r squared to represent x squared plus y squared. For x you need r cosine theta, and for y you need r sine theta. I don't have any of those three here, but somebody said, can I multiply both sides by r? And I do have the r squared to the left and I have r cosine to the right, and that becomes x squared plus y squared equal to x. And if I bring the x to other side, I can complete the square, and that becomes x squared minus x plus 1/4 plus y squared. I take half of the one and I square it and I add it to both sides. This is x minus 1/2 squared plus y squared equal to 1/4. Therefore, this is equation of a circle that h and k is 1/2 and 0, and the radius is 1/2. Therefore, I change r equal to cosine theta to this equation in Cartesian form. Do not leave in this form because this is a general form. I need it in the standard form that I can see the center and see the radius. Therefore, the graph of these two are the same. The graph of this one, the h is 1/2, the radius is 1/2. 1/2 here, which is 1 and 0, 0, 0, 1/2 here and 1/2 here. That's the equation of a circle. R cosine theta should be exactly same graph. Okay, let's see if we are right. Theta and r. If theta becomes 0, cosine of 0 is 1. If theta becomes pi over 3, I just pick up pi over 3 because I know the cosine is 1/2. And I pick up pi over 2 is 0. And if you look at that graph, at theta 0, your r is 1 because that's your polar axis. And that's your pole. At pi over 3, your r is 1/2. See, the r reduces. And at pi over 2, your r is 0. Therefore, you only needed 90 degrees for half of the circle. Somebody said, what happens if I put 2 pi over 3 here? Cosine of 2 pi over 3 is negative 1/2. 2 pi over 3 is 120 degrees. 120 degrees here. Negative 1/2 is a reflection of 60 degrees over the polar axis, is right here. And what happens if this becomes pi? Cosine of pi is negative 1. If this one is a pi, negative 1 go to backward, and that's exactly 180 degrees to graph that. Then from today you have to know r equal to a cosine theta. That's a single angle, not 2 theta, single angle, and a can be positive or negative. But whatever a is your diameter. Because here your a is 1 and your diameter is 1. If I make my a 2, when the theta becomes 0, r become 2. Then your diameter becomes 2. Therefore, a is your diameter. Okay, then somebody said, what happens if I take that r and I said 2 cosine theta, that's a circle, I added a 2. Somebody said, I don't know what that is. That shifted up 2 units. In here I have an argument. And my argument is, whenever you have a Cartesian, and this place, this ordered pair or this cell located at 3 and 2, this is the house you're living. You can sell that house and move over here. That's called moving. That's called shifting. But whenever you have a polar ordered pair and r equal to 2 cosine theta is here. I'm just making it up, and I should not graph this one because you're going to get upset because that was not equation of my circle I just drew. This is r equal to cosine theta with a diameter of 1. Then here your r equal to cosine theta. If I put 2 right here, your diameter become 2. Therefore, your r is always 2 cosine theta. By adding a 2 to it, I'm just increasing the radius. I'm not shifting. I'm increasing the radius. Then let's go right here and say what is the graph of theta and an r. And in here I'm going to make this a 1 just look like this because this one was r equal to cosine theta, and I'm going to make this one 1 too. Therefore, when it's theta, I added 1 to the radius. When it's power 3, I added 1 to the radius. When it's power 2, I added 1 to the radius. Therefore, you saw this one does not reach the pole. But when it's 2 pi over 3, I added 1 to the radius. And when it's pi, I added 1 to the radius. Ooh! Here, when I add 1, instead of 90 degree reaches the pole, 180 degree reaches a pole. Let me see what does the graph look like. Well, when theta is 0, the r is 2. When it's power 3, it's 3 half, 1.5. When it's pi, is 1. Therefore, the graph so far, my r is 2, r is 1.9, 1.8, 1.6, 1.65, 1.5. And it gets smaller and smaller to get 1. It gets smaller to half, and it gets 0 when it gets to 180 degrees. Let me continue this. Maybe this one is half of my graph. Therefore, if it's a circle, you finished at pi. But if you add 1 to it or subtract something to the circle, you got to keep continue. Therefore, I'm going to put 4 pi over 3. 4 pi over 3 is here, and the cosine is negative 1/2 plus 1 is 1/2. See, that repeat itself. All this number gonna repeat itself. And 4 pi over 3 is here. It came back to 1. And I have a trace here. At 3 pi over 2, cosine of 3 pi over 2 is 0 plus 1. At 3 pi over 2, I came to 1. And what is at 2 pi? At 2 pi, come back to 2. Oh, that's my graph. And that graph is nothing except look like a heart. And if something is wrong with your heart, you have to look at a cardiologist. Therefore, from today, if you see a picture of a heart, you better call it cardioid, means shape. That's the cardioid. Therefore, if you take a circle and add the same, whatever the diameter is, you add the same much to the r, you get a cardioid. But somebody said, what happens if I have r equal to negative cosine theta? Nothing wrong with that. This is exactly the graph of r cosine, except this r become a negative. Whatever you had a positive, it become a negative, and this become a negative, and that's become a 0. Power 2 become positive, and pi become a positive. Therefore, it's exactly a graph of a circle which you flipped it on the other side. Then, if I go back right here, and I said, what is r equal to 2 minus 2 cosine theta? It is the graph of a cardioid. You just reflect it along the line of theta equal to pi over 2. Then, from today, you have to know, if you go to your graphing calculator, and you said, I need 3 cosine theta. Make sure your angle is only from 0 to pi. Somebody said, can I put pi over 2 right here with an increment of 15 degree? I said yes, but this one I need to set up my window maybe -4, and this is -20. I go -4 to 4 with a scale of 1. A scale of 0.5 is good in here. And see, I got half a circle. Somebody said, why half a circle? Because I put only here 0 to power 2. If I make it pi, you get a full circle. Somebody said, can I put 2 pi in here? I said, sir, yes, you can put 2 pi. But you're gonna go around the curve twice. Therefore, if tomorrow I ask you to find the area of that, you have to go 0 to pi. If you put 0 to 2 pi, you double the area. But somebody said, what happened if I insert a negative in front of that? I said, the graph is the same graph, except it goes on the other side. But somebody said, what happened if I write 2 plus 2 cosine theta? I said, because this is a graph of a circle, but you're adding 2, you're increasing the radius. Therefore, when it is pi over 2, the radius becomes 0 for that portion. But when you add 2 to it, therefore your radius becomes 2. And because these two numbers become the same, you see a cardioid. The cardioid has a cusp right here. You cannot find the area by going from 0 to 360. Cardioid does need 360 degree. Circle need only 160 degree, 180 degree. What circle? Any circle that the R is not fixed. This is R is 2, 1.5, 1.6, this and this, and R0. See, R is not fixed. R is changing. When R changes, you need 180 degree. Unless R changes and the graph become a cardioid, because all this R is different. Therefore, all are different, but because it's not a circle, you need 360 degree. Somebody said, okay, but what happens if I go right here and put a negative between them? This is just like a circle. You flip it or revolve it across the line of theta equal to pi over 2. That is become a cardioid. The cardioid go on the other side. Then from today, I'm going to follow you with a strategy. The strategy is, how do you graph polar coordinate? Number 1, does graph passes through the pole? At the pole, R is 0. Therefore, if I ask you, R equal to sine of theta, does my R become 0? I said yes, when the theta becomes 0, when the theta become pi, when the theta become 2 pi. Then you're gonna draw yourself a table with a theta and an R, and you're gonna say 0, pi, and a 2 pi. I really at this moment don't know how many degrees that graph is required. I'm just gonna put it and I'm gonna graph it, then I'll learn. Between 0 and pi, I have some friendly numbers. One is pi over 2. Here you can put pi over, is that a sign? I'm going to put pi over 6, which is 1/2. And here I put 5 pi over 6. Therefore, sine of 0 is 0, because you told me R is 0. At pi is 0, at 2 pi is 0. But for power 6 is 1/2, for power 2 is 1, for 5 power 6, 1/2. Let me see what is my graph, then I'm going to keep going. I have 0, power 6 is 1/2, power 2 is 1. Oh, that's half of my circle. I don't need 2 pi. I think I'm finished here. At 5 power 6 is 1/2, at 180 degree is pi. Therefore, that is a graph of a circle. What kind of a circle? Is a circle that the center is in the Cartesian. Your h is 0, but your k is 1/2, and your radius is 1/2. I bet you that Cartesian form is x squared plus y minus 1/2 squared equal to r squared. Somebody said, how can I get that from this? I said, remember, in order to change it to Cartesian, you need r squared. I don't have r squared, I multiply by r. I need r sine theta, because I multiply by r, I'm going to multiply by r. And that becomes x squared plus y squared equal to y. I'll bring the y to this side, and I'm going to complete the square. I'm going to put plus 1/4, and I'm going to put a plus 1/4 here. This 3 is a perfect square, which is y minus 1/2 squared. X does not have any shift, equal to 1/4. See, I got it right there. Therefore, this is a graph of a circle, needed 180 degree. Somebody said, can you show it to me? I said, yes. If you go in here and say sine of theta, you need only 180 degree. Boom, you got that graph. Somebody said, let me change my window, my r, from -2 to 2, and even my x from -2 to 2. That's got a little bit better. But somebody said, what happened if I change this one and I put a negative in front of it as a negative coefficient? I said, that negative has nothing to do with diameter. That's a direction. You flip your graph right there. Therefore, this is nothing except the sign of infinity. No, that's 8. 8 is produces with 2 sign. Somebody said, I like infinity. Infinity is produces with a cosine and a negative cosine. Therefore, if you are looking for infinity, you need the 2 cosine, a positive and negative. For 8, you need a sine and a negative sign. Okay, then from now on, you have to know. The first thing you have to know is the graph passes through the pole. Right now, I know if I ask you r equal to 2 sine theta, you better say the center is on the line of theta equal to power 2, and the diameter is 2. Means the diameter r is 2, and this one is power 2. The middle of it is 1 and power 2. The radius is 1. And here you go and draw yourself a circle, and this is your trace. And at the pi, you finished. Next, what happens if I take that r and add the same number as a radian, like a diameter? If it's 2, I add 2. If it's 3, I add 3. If it's 4, I add 4. In here, the graph is going to become exactly like this, except you are adding 2 to the radius. If this one becomes 0 degree, sine of 0 is 0, you add 2. If this one is 60 degree, sine of 60 degree, 1/2, 1/2 times 2 is 1, you add 2. If it's 90 degree, the sine of 90 degree is 1, times 2 is 2, you add 2. See, these 3 give you here, here, and here. But when you are adding 2, you made it 4. At power 6, you made it 3. At pi, you made it 4. Oh, here is 2. I don't know why I put 4. Here is 2. You made it 3. Here you made it 4, and see, my graph is like this right now. But what happens if it's 5 power over 6? At 5 power over 6, you have sin of power 6 is 1/2 times 2 is 1, 1 plus 2 is 3. It reflects exactly that point. But what happens if it's pi? Oh, sin of pi is 0, 0 times 2 is 0 plus 2. That point become right there. See, that's the 0 degree, 2 and 0, and this is 2 and a pi. And this one was 4 and a power over 2. The question is, these are my trace. And if I put 3 power over 2, sin of 3 power over 2 is -1. -1 times 2 is -2. When I add 2, it becomes 0. Then your R gets smaller, smaller, smaller. From 2 become 1.5, 1, and a 0. Boom! These are my trace. But what happens if it becomes 2 pi? Sin of 2 pi is 0 plus 2 is a 2. It comes back to where it starts. Therefore, that is how you graph a polar graph. Therefore, if you have R equal to A cosine theta, that's the circle, the diameter is A, R equal to B, no, let me call it A plus B cosine theta. If A become equal to B, that's the cardioid. And you need to know that the graph of a cardioid is nothing except a graph of a circle that you are adding the same number as the diameter to it, and that becomes a cardioid. But somebody said, okay, I have 2 plus 2 sine theta. 2 plus 2 sine theta. I said, yes, that is the graph of a cardioid. But I need to 2 pi. I need the 2 pi, and my cardioid, I had more radius. I'm going to go from -5 to 5 and a 1, -5 to 5 and a 1, and I'm going to graph. That's the cardioid. If I put this one right here in negative, cardioid go down. If I, instead of that 2, put 2 minus 2 cosine, the cardioid is symmetric with respect to the polar axis. If I go and put right here 2 plus 2 cosine, cardioid is symmetric with respect to a polar axis. Therefore, we talk about cardioid when A equal to B is a cardioid. If A is 0, is a circle with the B is the diameter. And we talk about horizontal line, we talk about circle, we talk about vertical line, we talk about cardioid. Next video, I'm going to say what happens if A is less than B. What happens if A is greater than B? But when A is greater than B, what happens if the ratio is between 2 and a 1? And what happens when the ratio is greater than 2? All of them going to have different type of graphs, and you need to know these for either in Cal 3 or finding the area of polar graph. Thank you, and see you in the next video.